Hello, this is going to be your values of trig functions on the unit circle notes. The blank copy of this is on Classroom in this assignment. And part of the assignment is I give you a bunch of points and you have to find what the angle is on the unit circle. So you would just look up the point and see what the angle is. For example, if the point is negative root 2 over 2, negative root 2 over 2, I know the angle was 225 or 5 pi over 4. Or if the point was 0, negative 1, I'd know that the angle is either 270 or 3 pi over 2. This assignment is a little bit different than that. It's actually just gives you some point that it says is on the unit circle. And the first point here, this is on the unit circle, negative 1/2 and root 3 over 2. But I'm not looking for the angle. I'm looking to see what is the sine and what is the cosine of whatever that angle is. I don't care what the angle is. I just want to know what the sine and cosine are. And so I want to remind you that on the unit circle, that x is cosine theta and y is sine theta. And what you're going to find is this assignment's actually probably a lot easier than you thought, because you just have to look at what is the x value. If you know it's on the unit circle, then cosine theta is just that x value, negative 1/2. The sine is just the y value, root 3 over 2. And that's it. That's all I'm asking for in this assignment. There's nothing else to it. So it's pretty straightforward. Here, again, I have some point. It's on the unit circle. I don't know where it is on the unit circle. Well, actually, I do. I can see that the x is positive and the y is negative. So it's somewhere in the fourth quadrant, but it doesn't matter where, because all I'm looking for is just the cosine and the sine. I know that the cosine is here. So I write cosine theta equals 20 over 29, and sine is y. I like to think of it as sine and y both have that kind of whiny sounding long I. Like you say, oh, cosine, whatever, but sine is sine. Sine. Like, why is it sine? It's kind of whiny sounding. So that's how I remember which one it is. Here's another point. It's 0.8 and 0.6, and so I know that my cosine is the x-coordinate, 0.8, and my sine is the y-coordinate, 0.6. I wouldn't be able to find these angles without a calculator. I would have to use a calculator to find them. The very first one I'd be able to find because it's on the unit circle. If I wanted to know what angle it is, I would just have to find that point, negative 1/2 and root 3 over 2. Because x is negative and y is positive, I know I'm in the second quadrant. I'll even number these quadrants for you again, just as a review. And I know it's in the second quadrant, so I can just find where is the point, negative 1/2, root 3 over 2. It's here, so this is the angle. So I know that the angle is 120 degrees or 2 pi over 3. And I don't care if you give me the degrees or the radians in the problems that you have to do like this. 0, negative 1, that's actually on the unit circle. It's right here, so I know that the angle equals 270 or 3 pi over 2. But that's not what really matters to me. I just want you to recognize that the cosine is 0 and that the sine is negative 1. That's all I'm really looking for there. Here's another one. It's negative root 2 over 2, negative root 2 over 2. I know that cosine is the x-coordinate, and so I write cosine theta equals negative root 2 over 2. And this is my sine theta. And I don't write s, I write sine. And the theta, the little funny circle with or oval with a line through it, negative root 2 over 2. And that's all I'm doing. For this particular assignment, you don't have to find the angle. The reason I'm showing you how to find the angle is that you do have an assignment where you do have to do that. And so that's just showing you how to do it if you have to. I see that it's 225. And so I can write that, or it's also 5 pi over 4. That's less important to me than that you recognize that cosine is x. So I write cosine theta equals root 3 over 2. And sine theta equals a half. And that's it. That's really all there is to it. There's nothing else. There's no trick. You don't have to do any arithmetic. In this case, this is a point on the unit circle, so I can look up the angle. But if it's not, like in this case, I don't know. I'd have to use a calculator. Same thing here. And I also wouldn't get a whole number. I would get a decimal and I'd have to round, because the only angles that have perfect numbers and that work out and that have exact values are the angles from our special right triangles. And that's why they're called special, because they're the only ones that really have that property that they always, that their values, the values of the trig functions are exact answers, are not some crazy rounded decimal. If I look for it, root 3 over 2.5 is right here. And so my angle is 30 degrees, or pi over 6. And I will tell you that when I was your age, I actually had to look this stuff up in trig tables, which were a pain and gnarly. But lucky us, if we do ever have to find the angle, we can use a calculator, which is very nice. For trig and calculus, what you really, really need to know are these angles here. Which is why we're spending time on that. So if you have any questions, then please make sure to come to the class meeting, either Tuesdays at 2:15 or Thursdays at 11:15. And otherwise, you can always email me or private message me through Classroom. And I hope you have a wonderful week.